morning, sir.
Today we are going to discuss about the basics of aircrafts. You might have already studied, I think so. Okay. Anyway, we are going to once again recall everything. Okay. Today's topic is the fundamentals of aircraft engineering. What you have studied, in which we are going to discuss the basics of aircraft. Okay. Starting from the invention as well as the parts and engines, as well as the what are the principles used in the lift generation and other things, whatever we are going to have, those kind of things we are going to expose. Okay, it is going to be done by my students being here, sitting, having sit here. Okay, let's start with one by one. Okay.
Start.
So good morning, sir. So as we all know, Wright brothers from the USA in 1903 made the first successful airplane. So their airplane was called as Flyer and it flew about 12 seconds and 37 meters long. So an aircraft is nothing but is basically a machine which carries people and goods from one place to another. So most common type of aircraft is an airplane. So some types of aircraft are airplanes, helicopters, gliders, drones, and etc. So basically an aircraft is used for travel, transport or defense. So main parts of the aircraft are fuselage, cockpit, tail, aileron, landing gear and etc.
Okay. I need about basics of aircrafts. Okay, let's start with the others.
So I'm here to, good morning sir, I'm here to talk about the wings. So usually we use wings to generate the lift by utilizing the principle called Bernoulli's theorem. So first, what is meant by Bernoulli's theorem? So the air flows faster at the curved upper surface and slower at the lower flattened surface. So the faster airflow means it creates the low pressure. So in a flatter surface, in the lower part, it creates the high pressure. So this pressure difference is created it's generate the lift. So it's how the wings generate the lift to the aircraft.
The thing, but it's an airfoil only.
Yes,
Okay.
sir.
The airfoil, the top surface will be a curved one.
Yes, sir. The
Okay, bottom surface is a flattened one. If it is a curved one, the uphills, okay, will be very short distance. After that, it will be followed by the downhill only. So it will move fast in the downhill. Okay, I think it's a flat road. Okay, so it will move in the average flow and upper to the upper surface. So the velocity will be higher in the upper surface, but bottom surface will be lesser. So that we can relate. How can we relate the velocity with the pressure?
The pressure is directly proportional to
Velocity. So in the, is it correct, anyone?
No, sir, inversely proportional.
Okay, it is inversely proportional. So that in upper surface it is faster, velocity is faster, so pressure will be lower. Okay. So in the bottom surface we have pressure, higher pressure. So whatever if it higher pressure, you push up. So the lift will be generated in the airfoil. Okay, because of the pressure difference. Generally is called as pressure difference. It is called as the Bernoulli's principle. Okay. Is there any other primary control surfaces out there? I think so.
It's first one is the primary control surface. In the primary control surface, it includes the aileron and elevator and rudder. So ailerons, we use ailerons for the roll control and the elevators for the pitch control and the rudders for the yaw control. And there is another thing called the secondary control surface. In secondary control surface, it includes flaps, slats and the spoilers. So it's assist takeoff, landing and controlling speed and lift.
Okay, now a question is there for all of you. Okay. What is spoiler? Generally, spoil means what? The life is spoiled. It means destroyed. Okay. Here, spoiler. Which one will be destroyed? Okay. It is used in landing. Okay, so during landing, why the spoils are used? Why?
So vibration.
No. To reduce drag means thrust will be higher. During landing, why thrust is more? Should thrust will be no more? Thrust must be reduced. Okay. So to reduce the thrust, okay, the forward movement will be reduced. So that the spoilers are used. That means of creating more drag and decreasing the thrust. So thrust is spoiled. That is called as spoilers. Okay. I said other parts of the primary as well as secondary control surface are there. What is the purpose of flaps? Use. Secondary control surface. Generally, it is a high lifting devices. It is a they are high lifting devices. The high lifts are needed. During takeoff, high lifts are immediately you have to have the emergency purpose, like fighter aircrafts. Okay, those kind of aircrafts is the short takeoff, during short takeoff after the landing. This is TOS. Okay, so that the flaps are needed. That is called a secondary. Okay, any other things you want to tell?
Start.
Yes, sir. There's one more important thing in here. It's called NACA, the National Assembly Committee for Aeronautics. So there's so many types in there, like 4 series NACA and 5 series and 6 series.
Okay, these things you know. Okay, that is National Advisory Committee for Aeronautics. Okay.
Yes.
Yeah, your side from.
So let me talk about the aircraft engine. First of all, why do we need aircraft engine? It means to produce thrust. So by means of producing thrust, it means to pushes the aircraft in a forward motion. So by moving in a forward motion, the wings can generate lift and the plane can fly. So for this to produce thrust, we can need aircraft engine. So
I need one of the types of engines.
so let me talk about types of engine means turboprop engine, turbo shaft, turbojet, and turbo fan and ramjet
I
engines.
know where turbo shaft engines are used.
So it will be mainly used in helicopters, so like that. So it will
Passenger aircraft and commercial passenger aircraft, what type of engines mostly used?
turboprop engine,
Any other?
turbojet,
Actually, turbo fan engine.
fan.
Turbo fan engine is mostly used in
Yes, sir.
commercial
It's mainly
pilot, that is the
Wow.
passenger aircraft. Okay, from your side.
So I'm here to talk about the empennage of the aircraft. Well, empennage is the tail part of the aircraft. It consists of two main parts, horizontal and vertical stabilizer. The rudder is mounted to the vertical stabilizer, which controls the yawing of the aircraft. Yawing means nothing but turning the tip of nose of the aircraft right or left. And elevator is mounted to the horizontal stabilizer, which controls pitching of the aircraft. Pitching is nothing but lifting the nose up or down. Well, these helps in the elevator helps during the landing and takeoff of the aircraft, and all these things like elevators, rudders, and trim tab helps in keeping the flight stabilized during its cruise.
From your side, please.
So as she explained the lower part of the aircraft, I'm going to explain the first front part of the aircraft, that is called the cockpit. So cockpit consists of many buttons, important instruments, and many screens. Though it may look confusing, but every button screens also has very special tasks. So some of them are like altimeter, like when how much height the plane is flying, and also like airspeed indicator, like which helps to indicate how in which speed the plane is going, and also like artificial horizon indicator, like if the plane is flying in the straight line or it is tilted to an angle or something. And also there is a GPS control to locate where the plane is flying or the location is needed to travel. And also it contains radio to connect with the air control system in the down space.
The final question I'm asking, what is the difference between a symmetrical airfoil as well as a cambered airfoil? Generally, airfoil, I want to know that it is nothing but symmetric. There is a cross section of the wing. okay, crosses on the wing, which will determine the lift generation. Okay, the amount of lift generation. Okay. What is the difference between symmetrical and the camber airfoil? Symmetrical means what? Symmetrical
Angle of
airfoil.
attack is 0, sir, in symmetrical airfoil, while in camber airfoil, the angle of attack may be from 0.1.
No, you are telling that angle of attack is 0 for symmetrical airfoil.
Yes.
Is it correct?
No, sir. In angle of in symmetric airfoil, we generate lift at angle of attack 0.
No. Anyone please?
Sorry, sir. In asymmetric airfoil, we can able to generate the lift in the angle of attack 0.
No. In symmetric airfoil, both the upper surface and the
Lower surface are same.
same. Then what will be the percent difference?
No
No.
percent difference.
Then the lift will be 0.
Zero.
It will not produce any lift at 0 angle
Yes,
of
sir.
attack.
I told you in asymmetry.
It is. Okay. The main difference is at the angle of attack is 0, there is no lift
In symmetric airfoil.
in symmetrical airfoil. But in case of a camber airfoil, since we are having some camber, okay, even at 0 angle of attack, the lift will be produced. So there is the difference between the symmetrical and camber airfoil. So many points are there. We can discuss in the next class. Okay. Thank you all for your nice participation. Yes.
Thank you, sir.